Good morning to all of you. Myself Harprit Kaur from GPC Amritsar. Today we discuss the topic instruction format and addressing modes of computer architecture subject. Contents that which we are discussed: first is instruction formats, second single accumulator organization, journal register organization, stack organization, types of instruction format that covers 3 address instruction format, 2 address instruction format, 1 address instruction format, 0 address instruction format, and RISC instructions, and the last is addressing modes. First, instruction format. A computer uses many instruction formats depending on type of instruction. An instruction code is made up of bits, and separate group of bits in the code are called fields. Thus, an instruction format has 2 or more fields with different grouping of bits. Each field has same specific function. Instruction format cover करदा आ instruction code ਨੂੰ. Instruction codes जिद्दां सानू पता आ number of bits तो आपां उन्हां नू create करदे आ and ਇਹ separate ਜਿਹੜੇ bits ਹੁੰਦੀਆਂ ਆ ਇਹਨਾਂ ਦੇ groups ਬਣਦੇ ਆ ਉਸ groups ਨੂੰ ਆਪਾਂ fields ਕਹਿੰਦੇ ਆ. An instruction format 2 ਜਾਂ 2 ਤੋਂ ਜ਼ਿਆਦਾ fields ਜਿਹੜੇ ਕਿ group of bits ਆ ਉਹਨਾਂ ਨੂੰ use ਕਰਕੇ memory ਤੋਂ data ਨੂੰ transfer ਕਰਦਾ ਆ. Instruction formats. The most common field found in an instruction format are as follow. The first is operation code, that is opcode. The second is address part, and the third is mode field. Operation code specify करदा आ operations जेडे कि आपां perform करने आ and address part memory address जिथे data instructions जदों after processing or after operation जिहड़ियां instructions आ उन्हां नूं आपां memory ते store करदे आ. address part define करदा आ address of the memory. and mode field define करदा आ कि किद्दां जिहड़े operands आ ਉਹ define करनगे अपने आप नूं in the different modes. Next, operation code specifies the operations to be performed. It can be an arithmetical operation, logical comparison, or sometimes data transfer, increment, decrement operations, etc. Operation codes bits the transformation ਦੇ ਨਾਲ arithmetical operation, for example ਜਦੋਂ memory ਤੋਂ data ਨੂੰ 2 instructions ਨੂੰ ਲੈ ਕੇ add ਕਰਨਾ ਆ, multiply ਕਰਨਾ ਆ ਜਾਂ ਫਿਰ ਉਹਨਾਂ ਤੇ ਕੋਈ logical operation perform ਕਰਨਾ ਆ, data ਨੂੰ ਕਿਤੇ transfer ਕਰਨਾ ਆ, ਉਹ ਸਾਰਾ ਕੰਮ ਜਿਹੜਾ ਆ ਉਹ opcode ਦਾ, that is the operation code. address field ਜਿਹੜਾ ਆ ਉਹ memory address define ਕਰਦਾ ਆ or the address identify of a process or register depending on type of instruction. और ਜਿਹੜਾ address field ਆ ਉਹ define ਕਰਦੀ ਹੈ ਕਿ ਕਿੱਦਾਂ ਜਿਹੜਾ address ਆ register ਦਾ ਉਹਨੂੰ identify ਕਰਨਾ ਆ for the instructions. The mode field defines how the address of operand or its effective address is determined in case of indirect address. Mode field define करदी आ address of the operand or the effective addresses. Effective addresses define ਹੁੰਦੇ ਆ through the indirect addresses. Mode field define करदी आ only a single bit that defines which address is determined. Effective address in the form of direct address or in the form of indirect address. This is the instruction format that covers the address part, opcode, and I refers the mode field. It consists of 3-bit operation code, that is a 12-bit address and a 1-bit mode designated by I. Address bit ਜਿਹੜੀਆਂ ਆ ਉਹ refer ਕਰਦੀਆਂ ਆ 12 bits ਨੂੰ from the 0 to 11 that covers the address where the instruction is stored and processed. And the opcode defines only the 3-bit operation code, that is 12 to 14, and 1 bit mode. Mode refers only the 1 bit that is in a 0 or in a 1 bit. 0 refers the direct address and 1 mode bit refers the indirect address. Instruction format. The number of address field in a computer depends on internal organization of registers in the system. There are 3 types of CPU organizations. Instruction formats ਦੇ ਵਿੱਚ ਜਦੋਂ ਆਪਾਂ instruction CPU ਦੀ organization ਦੇ through store ਕਰਦੇ ਹਾਂ ਤੇ ਉਹਨਾਂ ਨੂੰ ਅਸੀਂ ਕੁਛ ways ਦੇ ਨਾਲ store ਕਰਦੇ ਹਾਂ. For example, number of address fields ਆ ਜਿਹੜੇ ਕਿ ਕੰਪਿਊਟਰ ਤੇ depend ਕਰਦੇ ਆ for the internal organization of the registers and ਇਹ internal organization ਆ ਜਿਹੜੀ register ਦੀ ਇਹ depend ਕਰਦੀ ਆ CPU ਦੀ organization ਤੇ. ਇਹ cover ਕਰਦੀ ਆ 3 parts. First is the single accumulator organization, second is the journal register organization and third is the stack organization. Journal register single register organization or single accumulator organization only covers a one or a single instruction. Journal register organization covers 2 or 3 registers and stack organization is simple as a push or pop operations. First, single accumulator organization. All the operations are performed within the accumulator register. In this type of instructions, only one address is used and the indicated operand is operated with the data value in the accumulator and the result is also stored in the accumulator. As we discuss, single accumulator organization register ਜਿਹੜਾ ਆ ਉਹ simple accumulator operations ही perform करता है and इस टाइप ਦੀਆਂ instructions ਦੇ ਵਿੱਚ ਆਪਾਂ simple एक address ही use ਕਰਦੇ ਹਾਂ ਜਿਹੜਾ कि operand ਨੂੰ indicate ਕਰਦਾ ਹੈ. For example, the instruction written in assembly language as load A and add B. There is an operation A plus B. First of all, A is loaded into the accumulator and the instruction is performed load. A ਨੂੰ load ਕੀਤਾ ਆਪਾਂ accumulator ਤੇ and load instruction ਜਿਹੜੀ ਆ ਉਹ perform ਕਰਦੀ ਆ operation. Next ਹੁਣ A ਜਿਹੜੀ ਆ ਉਹ accumulator ਦੇ ਵਿੱਚ stored ਆ and next operation is A plus B, then add B. B performs the accumulator operation and the result is A plus B. Automatically assess the accumulator in it because it assess only one address is used in this single accumulator organization. Journal register organization. This organization needs 2 or 3 address fields. 2 addresses are of 2 operands and either the result is stored in any one of them. If only 2 addresses fields are there or the result is stored in a third register, thus including 3 address fields in the instruction. Journal register organization सिर्फ ਆਪਾਂ 2 ਜਾਂ 3 address fields ਦੀ ਹੀ ਜ਼ਰੂਰਤ ਹੁੰਦੀ ਹੈ and 2 operands ਦੇ ਲਈ 2 addresses and ਅਗਰ result ਜਿਹੜਾ ਆ ਉਹ ਆਪਾਂ ਕਿਸੇ ਹੋਰ operation field ਜਾਂ instruction ਦੇ through store ਕਰਾਣਾ ਆ then ਆਪਾਂ third register ਜਿਹੜਾ ਆ ਉਹ include ਕਰਦੇ ਆ for assessing the instructions. Example, the following instruction uses 2 address fields, add A and B. Here A and B are the addresses of the 2 operands. They are added and the result is stored in the address A. Thus, the instruction is equivalent to A plus B. For example, like this. ਜਦੋਂ ਆਪਾਂ A ਤੇ B ਨੂੰ ਐਡ ਕਰਦੇ ਹਾਂ ਐਂਡ ਐਡ ਆਪਰੇਸ਼ਨ ਜਿਹੜਾ ਹੈ ਉਹਨੂੰ ਸਪੈਸੀਫਾਈ ਕਰਦੇ ਹਾਂ ਦੈਨ A ਤੇ B ਅਕਮੂਲੇਟਰ 'ਚ ਸਟੋਰ ਹੁੰਦੇ ਆ ਫਿਰ ਇਹਨਾਂ ਤੇ ਆਪਰੇਸ਼ਨ ਪਰਫੋਰਮ ਹੁੰਦਾ ਐਡ ਇਨ ਦਿਸ ਫਾਰਮੈਟ A plus B and stored result in same as in a operand. A operand ਤੇ result ਜਿਹੜਾ ਆ A plus B ਦਾ ਉਹ store ਹੋ ਜਾਏਗਾ. The next is stack organization. A stack is a storage device that stores information in such that The item stored last is the first item retrieved. The operation of a stack can be compared to a stack trace. The last tray placed on the top of the stack is the first to be taken off. Stack storage organization ਦੇ ਵਿੱਚ ਇੱਕ stack storage device ਹੁੰਦੀ ਆ ਜਿਹੜੀ store ਕਰਦੀ ਆ information ਨੂੰ in the last in first out manner LIFO. Stack operation work ਕਰਦਾ ਹੈ as a stack trace. For example ਜਿਹੜੀ tray last ਤੇ place ਕਰਾਂਗੇ ਉਹਨੂੰ top ਤੋਂ take off ਕਰੂਗੀ. The stack in the digital computers is essentially a memory unit with an address register that can count only the register that holds the address of the stack is called stack pointer, because the value always point of the top item in the stack. Here the stack pointer stores the top address of the item in the stack. Top item in the stack pointer SP ਹਮੇਸ਼ਾ ਜਿਹੜਾ ਟੌਪ 'ਤੇ ਐਡਰੈਸ ਹੁੰਦਾ ਆ. ਫੋਰ ਐਗਜ਼ਾਮਪਲ ਜਿੱਦਾਂ ਆਪਾਂ ਐਗਜ਼ਾਮਪਲ ਲਈ ਆ ਕਿ ਲਾਸਟ ਟਰੇ ਜਿਹੜੀ ਆ ਉਹ ਟੌਪ 'ਤੇ ਸਟੋਰਡ ਆ ਐਂਡ ਉਹ ਫਸਟ ਟੇਕ ਆਫ ਹੋਊਗੀ, ਦੈਨ ਸਟੈਕ ਪੁਆਇੰਟਰ ਜਿਹੜਾ ਆ ਉਹ ਲਾਸਟ ਟਰੇ ਨੂੰ ਪੁਆਇੰਟ ਕਰੂਗਾ. The two operations of stack are the insertion and deletion of item. The operation of insertion is called push because it can be thought as the result of pushing a new item on top, and the operation of deletion is called pop because it can be thought of as the result of removing one item so that the stack pops up. These operations are simulated by incrementing and decrementing the stack pointer register. Stack organization ਦੇ ਵਿੱਚ ਦੋ operations use ਕੀਤੇ ਜਾਂਦੇ ਆ. The first is the push and the second is the pop. Push operation is for insertion and pop operation is for the deletion. ਜਦੋਂ ਵੀ ਕੋਈ item pop operation ਦੇ through ਆਪਾਂ delete ਕਰਦੇ ਆ ਉਹ remove ਹੁੰਦੀ ਆ, then ਜਿਹੜਾ stack ਆ ਉਹਦਾ ਜਿਹੜਾ stack pointer ਆ ਉਹ decrement ਕਰਦਾ. And ਜਦੋਂ ਕੋਈ item insert ਕਰਦੇ ਆ through the push operation, the stack is incremented, the stack pointer register. Computers with stack organization would have push and pop instruction which require an address field, thus the instruction push X. Here we have the instruction push X. Push and pop, there are two operations. Push is for the insertion. Here we push X. Push X means the data is inserted in the stack and the push the word at address X to the top of the stack, and the stack pointer is automatically updated this stack. Stack pointer ਜਿਹੜਾ ਆ ਉਹ automatically update ਹੋ ਜਾਊਗਾ through the push operation, and when we want to delete some items from the stack, then we use the pop operation. For example, there is a pop and pop X. Here pop instruction deletes the top of the item and the stack pointer is also updated automatically. Types of instruction formats based on the addresses. First is the 3 address instruction. Computers with 3 address instruction formats can use each address field to specify either a process register or memory operand. 3 address instruction ਦੇ ਵਿੱਚ computers ਜਿਹੜਾ ਆ ਉਹ perform ਕਰਦਾ ਆ 3 address instruction ਤੇ, means 3 address instructions ਲੈ ਕੇ ਉਹਨਾਂ ਤੇ ਇਹਦੇ 'ਚ ਆਪਾਂ workout ਕਰਦੇ ਆ, and ਇਹ specify ਕਰਦਾ ਹੈ one for the process register and second is for the memory operand. Here we have an example, x equal to a plus b into c plus d, a plus b c plus d into ਇਹਨਾਂ ਦੋਨਾਂ ਦਾ multiply. After the performing the a plus b and c plus d, both of the terms or both of the registers are multiplied and the data is stored in the x register. For example, first add a and b, add a comma b in the R1, that is the R1 register. First of all, it refers the memory organization. B stored in the memory, A also stored in the term memory, and after performing the addition it stored in the R1. The result is stored in this register. And same as in second, C comma D, the result of C and D after the addition stored in the R2 register. Then again here the A plus B result is stored in the R1 instruction, and C plus B the result is stored in this R2 instruction. Then again multiply R1 and R2. Here the result R1 and R2. Multiply the both registers R1 and R2 and stored in the register X in this format. After the processing, the register's multiplication is stored in the memory, that is in the X register. The next is the 3 address instruction. It is assumed that the computer has 2 processor register R1 and R2. The symbol MA denotes the operand at memory address symbolized by A. The advantage of the 3 address format is that it results in short programs when evaluating arithmetic expressions, and the disadvantage is that the binary coded instructions require too many bits to specify 3 addresses. Advantage 3 addresses ਦੀ ਇਹ ਆ ਕਿ ਜਿਹੜੇ ਸ਼ਾਰਟ ਪ੍ਰੋਗਰਾਮਸ ਹੁੰਦੇ ਆ ਉਹ ਈਜ਼ੀਲੀ ਇਵੈਲੂਏਟ ਕਰ ਸਕਦੇ ਹਾਂ ਆਪਾਂ ਇਹਨਾਂ ਐਕਸਪ੍ਰੈਸ਼ਨ ਦੇ ਥਰੂ ਇਨ ਦਾ previous example. And disadvantage is that the binary coded instructions ਜਿਹੜੀਆਂ ਆ ਉਹ ਕਾਫੀ ਬਿਟਸ ਲੈਂਦੀਆਂ ਆ 3 addresses ਦੇ ਵਿੱਚ ਡਾਟਾ ਨੂੰ operations ਨੂੰ perform ਕਰਨ ਦੇ ਲਈ. Next is the 2 address instruction. 2 address instructions. These instructions are the most common in commercial computers. Each address field can specify either a processor register or a memory word. In the 3 address register instructions, it specifies the processor register, processor word or a memory word. But in this 2 address instruction, it specifies the processor register or a memory word. In the 2 address instruction, there is a program x equal to a plus b into c plus d is as follow. First of all, this is a 2 address instruction, then we can use only 2 addresses, one is the operand and one is the address where the instruction is stored. Here a is stored, move, first of all a is moved in the R1 register like that, and then b is a moved in R1 register. Next step is add. Here we can add a plus b, that is a stored in the R1 and we add R1 and b, and the result is stored in the R1 register like that. The next move c in the R2 register, and same in this add d into the R2 register, and the result is also stored in the R2 in this format. Result is stored in R2 plus C in the R2 register. Here we have R1 and R2 again, and multiply R1 register and R2 register. Here we use multiplication mul operation R1 and R2 and move R1. Here after the multiplication the result is also stored in the again in the R1 register like that, and R1 move in the X for the results are all results are now stored in this X register, and the move instruction moves or transfer the operands to and from memory and the processor register. As we already discussed, in the 2 address instruction the data are stored in memory word and the processor registers in the above example discussed format. Next is the 1 address instruction. 1 address instruction use an implied accumulator. that is the accumulator. Accumulator is that term that stores temporary data. Accumulator register for all data manipulation. For multiplication and division, there is a need for second register. However, here we will neglect the second register and assume that the accumulator contains the result of all operands. The program to evaluate x equal to a plus b into c plus d as same. In the one address register, here accumulators are used, and for the multiplication and division there is a need of second register, and second register is neglected after the operation is performed. In this, here we can already said that the need of addition and multiplication, there is a need of second register. Then load, first of all load a, and these data one address instructions are stored in the accumulator that stores the temporary data. Here a is stored in the accumulator register when we perform the load instruction, and then add b in the this instruction that is already in the accumulator, like in that format. Add b. Here accumulator ਪਹਿਲਾਂ ਤੋਂ ਸਟੋਰ ਕੀਤਾ ਆ A ਨੂੰ, ਉਹ ਐਡ ਕਰੇਗਾ B ਇੰਸਟਰਕਸ਼ਨ ਨੂੰ ਜਿਹੜੀ ਇੱਥੇ ਆਪਾਂ ਲੋਡ ਕੀਤੀ ਆ, ਐਂਡ ਐਡ ਹੋ ਕੇ ਰਿਜ਼ਲਟ ਫਿਰ ਅਗੇਨ ਕਿੱਥੇ ਸਟੋਰ ਹੋ ਜਾਏਗਾ, ਅਕਮੂਲੇਟਰ 'ਤੇ। ਨੈਕਸਟ ਹੁਣ ਇਸ ਰਿਜ਼ਲਟ ਨੂੰ ਆਪਾਂ ਨੂੰ ਸਟੋਰ ਕਰਨ ਦੇ ਲਈ ਇੱਕ ਰਜਿਸਟਰ ਜਿਹੜਾ ਆ ਉਹ ਅਦਰ ਰਜਿਸਟਰ ਚਾਹੀਦਾ ਹੁੰਦਾ ਆ, ਜਿਹਦੇ 'ਚ ਆਪਾਂ ਅਕਮੂਲੇਟਰ ਦਾ ਰਿਜ਼ਲਟ ਜਿਹੜਾ ਆ ਉਹਨੂੰ ਪਰਮਾਨੈਂਟਲੀ ਇੰਸਟਾਲ ਕਰਦੇ ਹਾਂ, ਡੈਟ ਇਜ਼ ਦਾ T ਰਜਿਸਟਰ। ਨੈਕਸਟ ਸੇਮ C load, and same C is stored in the accumulator, and next D, add T, and both the result of C plus T is also stored in the accumulator like this, and multiply T. Multiply T means the result of A plus B is stored in T, and the C plus T is stored in accumulator. So the result is in this format MT. T means the memory, that is this register, and into accumulator, that means C plus D. Result is stored in same again in the accumulator, and here we need third register for storing the data of the T register. Here we use X. X is the register third, which we use for storing the result of the accumulator, stored the results of the A plus B into C plus D, that is stored in the accumulator, and transfer into the register X. All the operations are done between the accumulator register and a memory operand. T is the address for a temporary memory location required for storing the intermediate results. In the previous, the T is used for storing the previous temporary memory location, and then after storing that, transfer the intermediate results into the final register. Next is the zero address instruction. A stack organized computer does not use an address field for the instructions add and multiply. The push and pop instructions, however, need an address field to specify the operand that communicates with stack. Here in the zero address instruction, only the push and pop instructions are used for performing the operations that communicate with the stack. Here first of all push the item A, because A is inserted into the stack organization. Here push A, that is on the top of the stack, then A is on the top of the stack, then again push B, then now A is on a top of the stack, and after pushing B there is on top of the stack, that is a TOS on a B, that is a B is on a top of the stack, and the stack pointer is now available at the B position, and then A plus B, here add operation is transmitted, and this after the instruction add, the result is stored, A plus B result is stored in the top of the stack item. Next push C and push D. Here the top of the item is now on the stack is D. Then add and after adding C plus D, the result is on the top of the stack. Here again A plus B into C plus D. After adding A plus B and C plus D, the instruction is used multiply MUL, and now the result of C plus B into A plus B is stored on the top of the stack. Here next after using and storing the address on the top of the stack item, then after finishing this instruction we want to pop these all the operations for performing the next instruction. Now pop x means top of the stack ਤੇ ਜਿਹੜੀ item ਸੀਗਾ ਜੋ ਸਾਡਾ result ਸੀਗਾ ਉਹਨੂੰ ਆਪਾਂ store ਕੀਤਾ x instruction ਤੇ x register ਤੇ, and after that pop ਕਰਨਾ ਆ ਉਸ x register ਨੂੰ for the next instruction execution. Next is the RISC instructions. In the early 1980s, a number of computer designers recommended that computer use fewer instructions with the simple constructs so they can be executed much faster within the CPU without having to use memory. This type of computer is classified as reduced instruction set computer. Reduced instruction set computer 1980s ਦੇ ਵਿੱਚ design ਹੋਇਆ ਸੀਗਾ and fewer instructions ਨੂੰ ਲੈ ਕੇ ਉਹਨਾਂ ਤੇ work ਕਰਦਾ ਸੀਗਾ. RISC instructions. RISC instructions specify relatively few instructions, few addressing modes, and memory access is limited to store and load instructions. All operations done within the registers of CPU. RISC instructions ਜਿਹੜੀਆਂ ਆ ਉਹਦੇ 'ਚ ਕੁਛ instructions ਸੀਗੀਆਂ, ਕੁਛ addressing mode ਸੀਗੇ and limited accessing period ਸੀਗਾ for the storing and load instructions, and it mainly is restricted for the load and the store instructions when we communicate with the memory and the CPU. All other instructions are executed within the registers of the CPU without referring to memory. A program for RISC type CPU consists of load and store instructions that have one memory and one register address, and computational type instruction that have 3 addresses with all 3 specifying processor registers. Here there is an example. First of all, load the instruction R1 A into the R1, next B into the R2, and next C into the R3, and same again D into the R4. Here we store all the operands into the memory through the memory registers A into R1, B into R2, C into R3, and D into R4. Next add R1, R2, that is A and B, R1, R2, and result is also stored in the R1 register in this format, and same C plus D, that is in the R3 and R4. After processing the addition instruction, the result is stored in the R3, and next is the operation is that A plus B and C plus D multiplication. Here we store the result of R1, R2, that is A and B into the R1, and C and D into the R3, then R1 and R3, and after the multiplying the result is stored in the R1 instruction. Here store R1 into the X instruction, that is the register X. The load instruction transfers the operands from memory to CPU registers. The add and multiply operations are executed with the data in the registers without accessing memory. The result of the computations is then stored in memory with the store instruction. Next is the addressing modes. The way The operands are chosen during program execution is dependent on the addressing mode of the instructions. The addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is actually referenced. Here addressing modes ਜਿਹੜੇ ਆ specify ਕਰਦੇ ਆ execution of the program and how to modify and interpret